Hi everyone, welcome to our first presentation. We've got John Bamberneck from Bamberneck Consulting doing data mining malware using historical information for current investigations. If I could just remind everyone to have their phones on silent, and if taking a phone call, please step outside. And with that, I'll just kick it straight along. If you can give them a warm welcome.
All right. So, good morning, thank you. So, a little bit of an introduction. In addition to running my own consulting firm, I am a manager of a security vendor called Fidelis Cybersecurity. I manage the data mining and automation part of threat intelligence for our group. I also teach at the University of Illinois in Urbana-Champaign, about 200 kilometers south of the city of Chicago. Primarily to try to bring up some more people in our industry, because there's more work than I could ever do in my lifetime, and I need more people to help. One of the things that I'm known for is I do provide open source intelligence feeds, primarily on DGAs. This talk will cover another data set that I'm throwing out there on malware configurations, which we'll talk about as we go. And the last point is that I do run several takedown-oriented groups. A lot of my professional career is focused on ultimately prosecuting or high-level disruption of criminal threats. I focus almost exclusively on criminal stuff, not national security espionage level threats, because no matter where you are in the world, usually there's something I can do about a criminal problem. So the shorter version of this is that if I'm not burning things, I'm just unhappy, right? And I get bored. So my wife, the most dangerous words I could say in the presence of my wife is I'm bored, because she knows I'm going to cause trouble in something if I don't have something to engage my mind in. So to start with a problem statement, that kind of builds into what this talks about, right? If you're a CERT or an enterprise and you've got a single reportable event, right? You've got a malware infection of a system beaconing to a C2 or whatever, right? With one data point, right, there's no pattern, right? You've got a machine infected with something. So specifically remote access tools. A rat can be used by script kiddie, it can be used by intelligence agency, anything in between, right? But with just one data point, it's hard to have that context of knowing, is this threat something I really need to be concerned about? Or is this email with a rat attached just somebody who's just spamming the earth with something, right? So, is it a solitary event, or is there an actual campaign going on, right? The other part of the problem is, particularly, in logging, getting metadata, creating alerts, often we don't know the important pieces of information when the attack occurs, when the infection occurs, or whatever campaign that you're looking at. From one of the last talks from the Symantec talk, right, the average infection time or dwell time of an adversary is about 200 days, right? That's not because there isn't logs of the attack, it's because somebody didn't know what they were looking for at the time the attack happened, right? So being able to not know what you're looking for at the time of the observation, right? Many of you know this, right? There's millions of samples of distinct malware samples every day, right? That are different from things preceding to it. Now, the number of tools, it's much less, but malware samples, you're seeing 1 million distinct samples. Just in virus total, it can be anywhere between 400,000 and 700,000, depending on the time of year, right? And analyzing all of that is disproportionately difficult, right? And the last point is something important to me, right? One of the reasons that I provide open source data and just throw it out to the wild is that, I work for a company that sells a product, right? That's great, but the people most in need of protection aren't in a position to buy security products. They may buy AV, and that's about it. Ransomware, at least the SMB consumer part of that, right? The tools that enterprises have available to them are not the same that consumers have. And the reason that that's so prolific is that consumers just don't have access to these technologies, not at the price point we provide it. So throwing some of this data out there so that hopefully consumer-facing organizations can use that. And we'll talk a little bit more about the data set that I'm going to be giving away here in a little bit. So malware config extraction is another aspect of what I do. So given a malware sample, of pulling out whatever configuration items are available in it. Almost all or I should say every piece of malware has some configuration embedded in it, right? At the very minimum, it's got to have C2 information, right? Host name, IP address, port information, how to communicate, right? Beyond that, there's a lot of other configuration items in there. Varies by malware family, but getting that data into a repository, right? So given, a very large body number of samples and all of those configuration items, right? It provides an ability to map and attack a specific adversary to what they have done historically, right? And predict, in some cases, predict what they will do in the future, right? And then using that, you can provide an up-to-date list of indicators that matter. For those of you who probably consume threat intelligence feeds, probably the biggest problem that you would face is that there's a whole lot of indicators shoveled down that are no longer relevant, either machines that are cleaned, domains that have been taken down, any number of things, right? Given configurations and a historical body of information, you have the core basis of tools to say, you know what? This malware once beaconed to this host name and this port, it's no longer a C2, no longer listening. It's not a relevant indicator, and you could take it out. Okay. The other aspect of this, given hundreds of thousands of samples, right? Dynamic analysis, is good, but it takes time, right? For sandboxing, it could take 2, 5, 10 minutes per sample, right? And you've got to have a big data set or a data center to do all of that. This research is based on static analysis, namely just a set of Python scripts or whatever your particular language of choice is, ripping apart a binary says, I care about this piece of data, this piece of data, this piece of data. That is very fast, right? And I could process 100 gigs of malware just doing static analysis probably in about 4 hours. Give or take, and that's not without doing any really significant enhancement. So I can process a whole lot of malware very quickly and then use that to create selection criteria of what do I send to sandboxing, what do I send to reverse engineers to try to make the process of malware processing a little bit more efficient, right? But this is talking strictly about static analysis. And the idea is you want to automate as much as possible, right? To limit the use of your resources and compute cycles and limit the use of people. Because again, we're facing a labor shortage and certainly reverse engineers, which is a very highly skilled and highly paid, niche within information security. And all of the security companies are poaching like mad everybody else's reverse engineers. So creating some set of tooling to minimize the need of having reverse engineers. Okay, so given a body of malware, VirusTotal is a good place to start, but there's several other programs that we'll talk about here in a minute. Right? Yara is a good regular expression-driven engine to analyze malware and identify it by families. So simply create rule sets with regular expressions and say, this is Dark Comet, this is NJRAT, this is Dire or NeverQuest or so on, right? To create some pre-selection criteria. Yara is its own topic, so I'm not going to go into it in great detail. Third step is running some kind of decoder that tears apart a given binary and says, here are the configuration items I want, and then display that back to you. We'll talk about that third set here in a second. All of this is free, aside of the sources of malware for VirusTotal, with one important caveat, and I'm not sure it's in my slides, but for those of you who protect organizations and enterprises, right, you probably have anti-spam, anti-malware solutions that filter your email, right? And you think about all the stuff that's blocked and dumped into a bit bucket, never seen by a consumer, right? That is a huge free source of intelligence for your organization, right? Of mining those spam folders for malicious documents and malware and getting, relevant information of who's targeting your organization. No one can sell you that, right? If somebody's targeting you, the only person who's going to see it is you. So mining those spam folders and things that are otherwise rejected and never get to end users is certainly a free source of intelligence I would encourage everybody to do. Right? But beyond this, all of this is open source. Yara and a lot of the rules are open source, and some malware decoders are open source. We'll talk about in another slide, right? So what can you do with all of that information, right? Certainly, if you've got C2 information, you could try to do sinkholing, right, for victim notification. Some organizations do that. This talk will be mining data for correlations. So this is a very useful tool set that I've used in several investigations, not investigating one breach, but investigating the entire user base of a given malware family of hundreds, if not thousands of actors, right? So that mining is very useful, and we'll talk about that, right? But you can also mine for indicators and pieces of information that didn't seem relevant at the time that have become relevant. And I'll show you some examples as we move on, right? So one of the big important pieces of this, like I said, is that static malware decoder, right? Kevin Breen, not an employee of mine, but does great work. I'd encourage you all to take a look at it. He's got a GitHub of malware decoders, mostly rats, about 3 to 4 dozen, a couple of non-rat related items, right? That he puts on GitHub and he puts it out there for free. So totally open source. It's Python, all does static config ripping. The output is a text file that you can put into XML or JSON or whatever particular format you want, right? He very actively develops it, so if you have any things that you see out in the wild, he'll work on that. Many malware authors will make changes to their code and their tools explicitly to get around what Kevin Breen is doing, right? And you could see some of his work live on malwareconfig.com, right? So malware sources, for sources of malware, VirusTotal, right, is a good piece. Microsoft has a Virus Information Alliance program where they work with security companies and enterprises to share security relevant information. They do that for free. So I would encourage you, any of you in organizations to take a look at that program. There are other malware sharing programs where if you have X number of binaries, you can share and get access to other people's repositories. The Cyber Threat Alliance, there's a couple of others out there like that. And the internal sources, one of which I mentioned, your spam filters, right? Or for that matter, web proxies that are stripping malicious files or binaries on the wire. And I would argue that's the most important because that's malware attacking your organization, right? Nobody can sell that to you, all right? So given those malware sources, right, you can run these Python tools or things that you customly develop, right, to start getting some information, right? Every malware has different configuration items, right? They all have C2 information because malware needs to talk somewhere, but from there, the items get different, a different subset of configuration items. Not all of them are necessarily relevant for an intelligence purpose, right? There's a fair bit that you could probably discard, right? Whether something disables McAfee antivirus on install, probably not a relevant consideration. Other items, mutexes, paths, file names, registry keys, certainly are relevant, and we'll talk a few of those examples here in a minute, right? As an investigator, as somebody who does intelligence, right, I love free-form text fields in malware, or in malware builders, right? Because if you don't do default items or default settings, it is very difficult for a human being to enter something into a free-form text field that doesn't leave some artifact of who they are, right? Even people who create random, pseudo-random strings, right? It gives me the ability to correlate everything they are doing if they're not careful. And we'll talk a little bit about that in a couple of examples, right? But really do love free-form text fields. Mutexes are also very relevant for correlating, right? Most all malware builders, for the most part, have a button to randomly generate a mutex. Most attackers do not re-randomize their mutex or those settings between malware runs, which means even though it's a meaningless string of characters, right? Odds are, based on the law of statistics and math, they would not just randomly, occur or collide with other actors. So it again lets me see exactly what somebody has been doing historically. Here's a quick example of the configuration settings available in Dark Comet. Dark Comet is a free remote access tool that's been around for forever, really, and used by the entire spectrum of actors, right? If you look at hackforums.net, you've got the stereotypical 14-year-old kid living in mama's basement. Last year, we saw some sophisticated APT activity using Dark Comet targeted at financial institutions, right? So it gets the job done for a variety of actors. The first item you see in there is campaign ID. Many malware families have that setting. Guess 16 is the default value for Dark Comet. You know, domains, right? The C2 information, FTP information. Dark Comet has the ability to FTP off keylogs. In order for that to work, there has to be a username and password. So I've got authentication credentials for a third-party service that's available sitting in the malware sample, right? So I can log into a given attacker's FTP server and start mucking around to see, you know, who are they stealing keylogs for instance. Mutex, that's what Mutex looks like. And then, you know, version number, in this case, is probably Dark Comet 5.1. NJRAT, different example, a popular remote access tool with Middle Eastern actors, but certainly it's used worldwide, but certainly has a, you know, a density of people in the Middle East that like NJRAT. Again, you see the campaign ID in the first one, which is 17 ones, right? Meaningless data, doesn't tell me anything, right? But the odds are that there are two people who type exactly 17 ones in a free-form text field is quite low. So even though that data is otherwise meaningless, allows me to, with decent confidence, right, correlate every piece of malware this person has weaponized, assuming I've seen it, and see if C2 information changes or settings have changed or map them to victims if I have access to that information, right? As an example of sample output of all of this, you know, in earlier versions, I did CSV. Now we dump it into Splunk, right? Hash value, date, comment. And then you see the top three there is, it's got 2 domains, 1 IP address. That fourth line in there where I redact username and password, right? That's it, that, you know, about 15 to 20% of the time, there's credentials to a third-party service in a malware config, at least for Dark Comet, where I could start logging into things, right? Available in the clear and easy to use, right? I didn't feel entirely comfortable putting that on a slide in a public presentation. Yeah, but that server is down anyway, right? But you see, right? Unlike its host name, let's see, it's got alcazor.ddns, a no IP host name. The key server, or I should say the FTP key server, is a Russian domain name, right? So allows me to pivot off and get some other interesting information. This is an amalgamation of all the fields taken at one point, right? So you see there's all sorts of different fields used, so data normalization is kind of a difficult problem, which Splunk makes relatively easy. Not that I expect anybody to take a look at this stuff, but, you know, the entire corpus of configuration settings, you know, can be quite large. I want to say it's up to 300 different unique ones for all the malware that we're processing right now, right? Operationally, or I say internally, we put it in Splunk for our own purposes. Operationally, for sharing purposes, we have an external MISP instance. How many people are MISP users in the audience, out of curiosity? Not too many, okay. MISP is a malware information sharing project. It is an open source project to allow organizations to share data about malware with each other, right? A lot of certs use it. NATO has an instance that they share. So it provides a means to share malware information among organizations. So in this particular case, we use it to share our entire body of intelligence on malware, about 90,000 some odd configs right now, to anybody who wants access. Given, if you want access to this as we go through or after I'm done, just send me an email or give me your business card afterwards, and we get you access to our MISP instance to download some data, right? So why store all of that, right? You know, VirusTotal keeps a lot of information about malware, but it keeps information that's generated dynamically. There is some sandbox-aware malware, right? So VT or other sandbox solutions won't necessarily have the information, right? Static config ripping doesn't care about that because it's just ripping ones and zeros out of binary itself. The other thing is that sandboxes, will not necessarily give you all of this information. They will give you C2 information, right, because it sees the network traffic, maybe, but it won't necessarily give you campaign ID, right? That's not an API call, it's a string somewhere in malware. So there's a lot more information available in the configuration that might be useful that sandboxes don't have, right? But going back to my, one of my original points is that sometimes you don't know what you're looking for until the event is already passed. So storing that information historically, and we've got about a year worth of malware, right, allows me to look backwards in time and say, you know what, I found something now. Let me see how much that has occurred in the past, in the past year, right? The key to any successful law enforcement prosecution, just generally, but very much true in cybersecurity, is that it's easy to get all of your operational security stuff right as an attacker once. It is very difficult to get it right over the long term. Every time that we've managed to put somebody who's relatively sophisticated behind bars for cyber criminal operations is the ability to see what they've done over a long period of time and then look for the one time they screwed up to expose themselves. Whether it's malware campaigns or Silk Road, all of it has been successful because of the ability to correlate backwards. And that was my motivation in creating this tool, is to be able to say, all right, now I know what I'm looking for. Let me see what they've been doing the past year, 2, 3 years, and see if I can find the time they screwed up and expose their home IP address, right? And this has been very successful in doing that. So there are 3 basic things that I look for, right? Is when DNS points to new IP addresses, they're making some kind of change. We'll talk about various scenarios of that. But for instance, the higher end adversaries will tend not to have their C2s up and running 24 hours a day, 7 days a week, right? Their DNS, their host name, may only resolve 30 minutes for a 30-minute window while they're operational. So without passive DNS, right, which doesn't always work, and some other tools, you may never see where the actual IP address is. You'll have a host name, right, but only a small window of time where that's actually operational and resolving, right? So resolving all of that to keep that information, right? When configuration data maps to previous samples, there are many different scenarios where an attacker, has multiple campaigns, and they change many configuration items, but leave something the same, right? And looking for that one pattern where there's similar behavior allows for that pointing backwards of saying, this is what this person was doing 6 months ago, right? And when configuration data matches to future samples to say, hey, I know the combination of this mutex and this campaign ID means it's this particular actor. So when I observe something in real time that matches that pattern, I immediately know who it is and know something about them. Okay. So all configuration items, are either free form, checkboxes, are randomly generated, right? Some in and of themselves have no particular meaning, right? But things like campaign ID and file pass, are certainly important. Campaign ID being a free-form text field. File pass and file names. Usually attackers will have it maybe randomly generated, but they don't re-randomize between runs, right? There may be authentication information, but all of this seemingly disparate stuff, it can be correlated and lets you learn something about attackers, right? There's an incident response goal of, understanding, the motives of the adversary. Well, on a single data point, that's hard. But when you can establish a pattern of multiple data points, right, you might be able to, or you're better able to figure out what the adversary is really after, what their skill level is, and what their interests are. This is just a brief count, rudimentary count of campaign IDs of Dark Comet samples taken a few months ago. Generally in statistical analysis, the interesting data is the margins, the least and most frequently occurring. That is not the case here. The most interesting data is in the middle. The most frequently occurring data is default values. You see guess 16 up there. The least frequently occurring data is solitary data points. There's no pattern to be had there. The most interesting is in the middle, right? So you see a couple of interesting things in there. There's Kurban, which is Turkish for victim, right? Lets me know probably somebody who's Turkish of origin. I think there's some Vietnamese, or not Vietnam, Portuguese, vidima, is Portuguese for victim. So it lets you know some things just based on campaign ID, right? However, when doing that kind of analysis, sometimes interesting things come out. JSocket is a Java-based remote access tool. No longer, it's been disrupted, is no longer available. Same process of just doing counts. And you'll see the bold one there's August 24th bombing, right? If you saw a campaign ID in a solitary instance, right? August 24th bombing sounds nefarious. When I first saw that, that date reminds me of something, right? There's something that happened on that date, right? And in fact, there was, right? There was a Russian civilian airliner, or I should say two, right? Two domestic Russian airliners were bombed on that day, right? So based on that solitary data point, right, might give you an indication, right? Somebody's creating an oddly specific reference to a terrorist attack, right? Very easy to conclude, and probably blogs have been done based on just that kind of connection. Hey, this is terrorist-related cybersecurity attacking, right? Well, I decided to look a little bit deeper, right? Having this historical data set. I want to see every iteration of bomb in a campaign ID, and I see it right there. There's September 3rd, July 1st, August 24th, you see a bunch, 1st July, right? All points to the same host name, right? Which is a US, at the time I did this slide, was a US IP address. Zapdo is a dynamic DNS provider, right? So, the moral of this story is being able to look backwards, right? The solitary data point points, this could be terrorist-related activity, but looking at the context back a year, no, this is somebody who's just, his lexicon is that when he spams the world, he calls it a bombing, right? Hence 1st July and August 24th and September 3rd, right? So able, as a counter example, to say, you know what, I see a data point, let's look what else. Okay, that's not as nefarious as it seemed at the time. Correlating with mutexes, similar thing. Look at something that occurs somewhere in the middle of the spectrum. In that case, that's what a dark comet mutex looks like. The last 7 alphanumeric characters are what's randomly generated. So just taking a look at that, I'm able to sit there and correlate, that almost always, except for one data point, have a campaign ID of DOS, right? Might suggest their motivation of denial of service. Maybe it's somebody's initials, who knows, right? But now I can see every IP address or host name that person's used with relatively high confidence, right? The ability to have a collision on a 7-digit alphanumeric sequence that's randomly generated is not particularly high. So this is all probably the same individual or group, and I could see everything that they've done and as they've moved from July to December is all I have on that slide, right? It's a very useful tool to have there, right? Can also be used to feed domain generation algorithms, right? DGA feeds is one of the free stuff that I throw out there. So DGA data points are very interesting to me. TinyBanker has several things that it uses for a seed to do its domain generation algorithm work. Initial host name, which you see is the third item, base domain, an RC4 key, which is the second, right? And then TLDs, as you see at the bottom. So given those, I could tell you all 1,000 domains. Is this 1,000? I think one of the bottom items is number of domains. So I could tell you all of the 1,000 domains that malware sample is using based on that. Okay. Key point is that attackers know that we do this kind of analysis, and they actively throw mud in the waters, right? They know Kevin Breen is out there creating decoders. They know I'm out there creating decoders. They know I know a lot of DNS resolution and some of the stuff that I'm doing because I throw it over the wire for free. So they can create deceptive information, which I'll show you an example in the next slide, right? They can submit malware samples to VirusTotal or to whatever ecosystem they want that have C2s that point to somewhere else, right? Just because it points there doesn't mean it's inherently malicious. So in this particular example, this dark comet, right? Yeah, dark comet. You see in the third line, its C2 information is 8.8.8.8, which is Google's DNS server, right? Google doesn't need to run a Dart Comet controller. They have all of our search logs. They don't need to run a rat. They've got all they could ever want to know about us, right? But that's valid malware, valid config. I want to say this virus total. Yeah, origin 8th line is virus total. So valid information, right? But not actively in use, right? That there's no C2 that listens there. Now there's another scenario. It could be an attacker is using a custom packer or crypter, submitting to virus total, and wants to see if antivirus detects it, right? So even though this particular data set, this malware sample is not operationally useful, that mutex or that campaign ID, which you can't see on that, or no, campaign all, right? Those items might be useful in an operational attack later because they regenerate the malware with correct C2 information when they're confident that it won't be detected. I mentioned Kevin Breen's decoders before. Right? Adversaries have changed encryption keys to make detection more difficult, right? So when JSocket moved to version 2, the encryption key was a homophobic slur directed towards Kevin Breen by name, right? As a little indication that this author of this malware knew exactly who Kevin was and what he was doing to try to defeat his decoders, right? So there is active counterintelligence. And the point is everything we do is, in essence, public, right? And attackers can and will adapt to it, right? The other aspect of counterintelligence is DNS resolutions point in time. I talked briefly that adversaries will either, one, have their host names not resolve, or they're resolved to private IP address space when it's not in operations, right? So generally speaking, if you're seeing a DNS host name in somebody's list of IOCs that resolves to 10 dot whatever, you're probably immediately going to discard it, right? Which is not necessarily a bad decision, except that DNS is under the control of the adversary, and they can make that operational anytime, which is why it's important to have the entire corpus of malware configuration available to you. All right? So once a given host name is seen, you know, what can you do is doing that bulk resolution to look for changes. You could check to see if a C2 is up, just doing a SYN port check instead of doing the full three-way handshake. Processing historical malware to have that data set to be doing the correlations backwards. And then checking for things that resolve the private IP address space. Now that could just be bad configs, but usually that indicates a sophisticated attacker, right? If things are resolving to private IP address space, you know, 99% of the time, and then for 30 minutes is resolving to something on the open internet, odds are that's somebody who knows something about operational security, and that's somebody who you should be paying attention to, all right? We're close to out of time, and I want to have some questions. So I don't have, I'm not going to do a demo here. But again, if you want email to the MISP instance, drop me a line, give me a business card. We'll try to give access to you. The URL is there at barncat.fidelisecurity.com. Barncat is what we call a project internally. So I'll also be at the AusCert booth during the afternoon tea if people want to have questions, and I'll be here for a couple more days. So thank you, and any questions? I was starting, people are going to let me off easy. You know. The question was, why do people have campaign IDs, right? Versus knowing that we can correlate off of. A sophisticated subset of people who understand operational security would use a default value or leave it blank. Actually, erasing all of that data and leaving it blank would still tell me something, right? If I were committing criminal activity, I would use default values every day, right? For free-form text fields. Why do people do it? Ego, stupidity, wanting the ability to compartmentalize their operations, right? So if you're talking espionage, right, that level of things, you know, there is some understanding of compartmentalizing operations. You could do that all internally, right? But some do it in the malware for whatever reason, right? The answer varies. Personally, like I said, My rule is, step one, create no evidence, but I guess lucky I'm not a criminal.
If you're doing credentials harvesting, it's really tough to regulate globally, so campaign IDs will give you a good idea of where
Yes.
to test them.
Right. And the question was about doing credential harvesting and the use of campaign IDs in there to replaying things, right? Other questions? That was one easy question, one comment. Yes.
MISP, that's a service that everyone can sign up to and request for it to be added.
Yes.
Can we add to the database or how do we add?
MISP itself is software, right? It's available at misp-project.org. Anybody could put that up. It's just a web-based instance, right? There is the web portal itself where you can query things directly. It also has an API that's fairly simple to use. MISP has a correlation engine which allows you to correlate, disparate malware attacks based on whatever configuration items you want. I explicitly turned that functionality off in my MISP instance, because once I got to about 10,000 malware samples, it broke catastrophically because so many things correlated to each other. I just use it to basically, you can download all of the JSON blobs for the configuration items and then put it into an Elk Stack or Splunk or whatever. So there's an easy API to do that where you can just say, give me all of the JSON blobs and then dump that into something else to do your analytics. So it's just really a sharing platform in my particular case. Sir.
I wonder if you can comment on your experience on using big data analytics on this history.
The most interesting, the question is if I can comment on doing big data analytics on this data set. The most interesting work that I've done with this is part of law enforcement investigations, and I can't talk in great detail. But like I said, I have been able to do research in an entire ecosystem of users of X, and narrow in on specific attacks using it. One comes to mind that was related to a political assassination in South America. And using that data, I identified the home IP address of the specific person who operationalized that attack, right? I could go further, but that starts getting into the espionage stuff. I'm just like, here, right? I don't want to be in that dance space. If there's political assassinations going on, I'm just as easy to kill as somebody in South America. But certainly, like I said, there's fingerprints where you could do it and then run things all the way down to the individual. Does that answer your question more or less? Do I get one more question?
Yeah, one more. Yeah.
One more. You're the lucky one. Make it count.
I was wondering if you've got any plans to offer sticks or taxi formatted, please?
As far as I know, I've not done it. MISP has some plugins which allow you to output stuff in Stix or Taxi. I don't think that would work particularly well in this use case, mostly because the item everybody cares about is kind of the JSON blob of configuration items, right? And really, I just put that up there as just a sharing mechanism for people to do whatever. You can convert that into Stix Taxi pretty easy from there, I think. I would imagine, right? So, but I wanted to create something that was basically usable by anybody without kind of prejudice. Here's JSON if you want to throw it into Stix. Great, knock yourself out. If you want to throw it into Threat Connect, you could throw it into Threat Connect or Passive Total or pick a service. All right? All right.
Cool, thanks very much. And if I'll just pass on my apologies, it was remiss of me to not mention at the beginning that we use the OzCert 2016 app to lodge questions. I'll take you through in a moment, but just for the time being, we could all thank John for his presentation. All right, thank you. I've got to continue down the front, so I'll just get back in a moment, but I'll just take people through how to quickly vote so we don't have that same problem. So guys, if you do open up the app and click on the presentation, there's an option there to, this is an interactive session. It'll go green. If you click on that, it'll take you through to where you can read up on the speaker and lodge notes and also vote, and then also ask a question of which we'll field at the end. Please, if everyone could remember to vote on their presentations, and I'll leave you to it, and we'll have a couple of minutes before the next presentation.